Hello, everyone. I'm Greg Weaver. Welcome to The Audio Analyst. With episode 181, Siltech's Master Crown Cable, from June 30th of this year, I shared my experiences from the Master Crown Cable introductory press event held in Santa Fe by Siltech's U.S. distributor, Monarch Systems, just 10 days earlier. Today, I want to share some of the most significant portions of a conversation I had this past week with Siltech's driving force, Edwin Rynveld, the man who acquired Siltech in 1992 and who has guided it to its present position as one of the most respected, top-tier audio manufacturers in our industry today. Now, you may have noticed that I said I'm presenting significant portions of our conversation. I say that as it seems that both Edwin and I share a mutual gift of gab. We both enjoyed this conversation so much that our entire recorded conversation lasted over an hour, with us occasionally going off into the weeds about some of the minutiae of both audio design and psychoacoustics. That said, here is our abridged conversation. All right, everybody, here he is. Edwin Rynveld has taken time out of his day. It's evening there in the Netherlands, yes?
That's correct. 7 p.m.
And I'm thrilled that you were able to find time to talk with us a little bit, sir. I'm really grateful. I know that you were aware that I was pretty impressed with my time so far with the Master Crown Loom. It was an unexpected and remarkably pleasant surprise, and I'm not going to go into that too far. I'll talk about it in my other reviews and videos, but I wanted to talk with you about a couple of things with the cables, because first and foremost, this new S10 metallurgy, you used to use an alloy of silver and gold, and the gold was to fill the micro cracks and things in the structure, but this monocrystal of silver that you're using, this S10, do I assume this is somehow formed like the Ono continuous cast process, where it's just a very slowly drawn and carefully cooled process? Or how hard is it to make this monocrystal silver?
No, it's very often assumed that we use the Ono process. We don't, because that's basically a long crystal. It has been developed a long time ago.
Okay.
I got interested in monocrystal structures and amorphous wire a long time ago, I think in 1977, if I remember. There was the first conference in Tokyo. That was the time, if you remember, when you had the glass ferrite heads that couldn't wear anymore. You know, on Akai, Sony had their own version. Yeah. I think glass ferrite, something like that. Basically, that was a time of discovery or rediscovery of monocrystal materials that are mechanically much stronger. Okay. Well, our interest, of course, is the conductive properties of the material. And at the moment, with the very best monocrystal, you can gain a couple of percent in conductivity. That doesn't look very much, but it does a lot for various reasons. Not because of the conductivity itself, but it means if you have this higher conductivity, which we have now, up till 12% is the best that we can achieve. That means that there are very little errors in the crystal structure. They call that the lattice. The lattice is a kind of framework where atoms are placed in a certain position that you could say it's like they are magnetically coupled. They stay in a certain position and they absorb. They can accept electrons to bind with them. They are loosely coupled. So it's all conductors. You have electrons that can flow easily. Every error, every micro crack, every error in the lattice, for instance, because of pollution, let's say you have a little bit of another material in there, so a little bit of copper or a little bit of whatever it is, the lattice will have an error. Okay. And that means their electrons cannot bind there and they have to find a different paths. So it's a kind of a little jump of energy at a spot where you don't want to have it. And one of the amazing things of audio is that all these very little amounts of distortions are audible. Every new engineer that we have, and there are engineers with a PhD, so they're really guys that know their stuff, but every time they're very, very surprised that the most differences in errors, you could say, are so audible.
Yeah.
And this is something that you are probably, Greg, you're aware of with audio, that small changes, you tighten a connector of an interconnect, and suddenly it sounds better. And you clean it and you tighten it, everything is better. If you try to measure it with a sine wave, you don't find any difference. and it's very, very, that doesn't mean the sine wave is wrong, but music is, first of all, not a sine wave,
Not a sine
because
wave,
that's a
yeah.
continuous wave. The other thing is that if you have a sine wave, because of the noise level of measurement instruments, and we use the very best that we can get, that means we have a couple of these audio precisions, the top models that they have, but still they employ noise. And the noise in all these things is a kind of random noise that is kind of disturbing. With my experience how to set up a research program, when I entered the company in 1992, I set up proper research. So I started using quite good equipment, the best that we could get in the day. And we started measuring. And I did find that with all these measurement equipment, where you usually take a higher voltage, let's say 1 volt sine wave, you cannot measure the distortion because the noise level is too high. So what do you do as an engineer? You raise the voltage level. Still had to have a bigger difference between max and the noise floor, called the dynamic range.
In late June, I was privileged to visit Santa Fe when they had this press event to introduce these cables. Gabby was there. We had a marvelous time listening to these products. And one of the things that that kind of struck me was the massive size of these cables. And I mentioned to you in an email, and I wanted to see if you could touch on this for us. I've always felt, or more fairly believed, that all else being equal, lower mass, minimal terminations, least complex plating and interfacing would deliver the most exceptional results. And I got to tell you, the experience with these cables, which I'll be sharing with people in print and in a companion video, is absolutely stunning. Can you talk about how you guys hit on all these possible? I mean, obviously, I've looked at cable design. Some people call it a recipe. I look at it as like formula racing, where you have essentially 4 areas to work with. You have the conductor material, the insulation or dielectric material, the termination, and the geometry. And I tend to think geometry can be as important as any of the others. But you can only basically vary those 4 things to get what you want to get, right? I mean, that's basically it.
It's almost true. What you're saying is almost complete. But if we go in details, it's very difficult.
Sure. No, I get that.
Let's first start.
I'm amazed at how these cables. Look, I've been doing this for a couple of weeks, and I actually started off writing about cables. I did a thing back in the late '80s on loudspeaker cables. Are they a simple passive connection or a complex dynamic component? And I've listened to a lot of cables, and I got to tell you, this has been a remarkable experience. And I want to get into a couple of parts that, like how you got to where you are with these, because these are exceptional. And look, unfortunately, not everybody's going to be able to afford these things, but wow, if they can. This is performance that is sui generis. It is of its own kind. I've never heard cables like this before.
Thank you very much. So what we are doing, let's first start, let's try to make the story as short as possible, but still clear. Let's first start with the many dimensions that we have. So with cable, and that's very poorly understood, we have a variation of frequency, of current, and voltage. So these 3 have a big effect. Then we have the outside world. And the outside world means electromagnetic fields that are in your room. And they're really everywhere. If you would have a spectrum analyzer, you can see it. So there's all kind of things happening around you that you don't see. Then there is microphony in a cable. That means if your music is playing, the cable vibrates a little, and you don't want that to be transferred to a signal in series with the music, because it's not in time. What comes out of your loudspeakers is way later than what comes out of your source, be it a turntable or a streamer or a CD player, doesn't matter. There's quite a lot of time delay in your electronics. And it depends a little bit. If you have a tube amplifier, it's usually a little bit quicker, but if you have an output transformer, it's again a delay. The fastest amplifier we make that has a 15 nanosecond delay from input to output. I think it's the fastest in the world, but the reason it is so fast is because it's very simple. It's just a couple of tubes doing the whole thing. And that's called the Saga system. Still, the loudspeaker transfers it to energy that goes into the room, and there's some delay in the mechanics too of a loudspeaker. So there's quite a bit of delay. If your cable starts shaking, picking up the vibration from the music, and if it's microphonic, that means when it has to be silent, it's not silent. You get a kind of echo from the room in the signal, which is picked up, amplified again by the interconnects, by the amplifier. So it's a kind of a loop.
Sure.
So this is an acoustical loop that we have. Then we have an electromagnetic loop. Then we have a stress factor. That means that if you bend the cable, you don't want the properties to change. These things we can measure. We make sure that if we change it, if you bend it 100 times, that the properties are equal. If you stay on our cables, you can walk on it. I wouldn't recommend it on a daily basis, but anyway, you can. But all these things are very, very important. So you want a stable product that is always good and also is stable 20 years later because they're so expensive. And as a side story, if you look on internet, the highest price for a second-hand product is from Siltech cable. For a long time, even for 40-year-old models, people still pay 30 to 40% of the new price, and sometimes more. Some cables have become more expensive second-hand than they were new in the day. And there's a reason for it, because we have positive aging. Where's the positive
I was going to
aging?
ask you about that. That was something that when I first presented that in my earlier pieces, a bunch of people said I was insane. You can't do that. And I said, well, it's if you want to go into that positive aging thing a little bit, I think people would like to hear about it.
Okay, just very, very briefly, everybody knows what's breaking in. Breaking in is something in cars. The cars 10 years ago had a lot more than the new ones, but that's a different story. Breaking in is very often the mechanics. If you have a speaker, you can imagine it has all these surrounds and the spider. It gets more loose when it moves a couple of times. So depending on the material, it can be in a short time or a long time. You cannot give a general rule for that. People always ask, how long does the breaking in take for a Siltech cable? There's no real answer. So we say, well, we tell them there's no real answer, but I would suggest 100 to 200 hours, because that sounds fair. But in reality, it has to do with temperature. That's a constant, because room temperature around the world is usually in centigrade 22. What is that, 70 degrees or something like that in Fahrenheit?
Right.
So that's quite constant. So that means cables even break in when they are not playing music, just by the temperature. And why is that? The electrons move. The higher the temperature, the faster the movement, the random movement of the atoms is actually. And what is, if you make a cable, and you talked before the Dr. Ono process, a professor he is, but it's an interesting way. It is a slow way to make longer crystals. And that also implies that there is a crystal boundary. Also, because you have a given format, let's say you have a die with a hole in it, which can be a diamond, and you pull the soft material through it, or you press it. That's the better way. That's what Ono did, pressing it so that you're not pulling the soft wire and breaking apart the crystal structure. So you push it, it keeps more dense. But at outside, it's not an equal number of complete crystals or atom groups. The problem is then that you get incomplete crystals. Whatever the process is, even with our highly pure monocrystal wire, there are still errors always on the outside because of the making of the thing. So let's say we have a gap that here we have in this corner, we needed to have right in where my nose is now. You should have an atom, and it's not there. So if the other atoms move at a higher temperature, also when there's more current going through it, they move until, and that's actually a kind of random process, like noise. It's sometimes a little movement, sometimes bigger movement. Once in so many times it's the biggest movement, and then it clicks in place. So it locks in place, makes a complete crystal again. The conducting properties are improved, and the distortion goes down. So you still can speed it up by running current. Now we run into the next problem. That works perfectly well for a speaker cable and perfectly well for a power cord. But it doesn't do anything on a digital cable. It doesn't do anything on an interconnect. And certainly not because the currents are so low. And if you look at a phono cable, it's even worse.
Yeah.
So very often I tell, if they have RCM both sides, then I say use it temporarily, this cable. As you can also use a cable cooker, as they call these electric
I actually use
devices.
one for that reason.
Yeah, but they usually are very limited in current, and these manufacturers do that because they're afraid to kill the cable. And in our case, any cable that we make, even the thinnest one, they can have peak currents of 80 amps, so
Wow.
they will not break. So a lot of distributors said, why don't you make one? And we have one that we have in the factory. We use that for all the cables, and that one goes up to 200 amps.
Oh my God.
And that's a very short peak, which oscillates until it's zero. And that breaks in a cable in a few minutes, better than 2 years of playing. The problem is, if we would bring it on the market, you would got a lot of hazards and fires of cable catching fire and
Sure.
of other brands. So we certainly are not bringing that to the market. And what is then the difference between silver, gold, and copper? Silver and gold, they never oxidize at room temperatures. People think that because of silverware, but silverware, if you have 925 sterling silver, that means 7.5% is usually iron or nickel or copper to make it strong. And people can hardly believe it until they're in our factory. Even a big wire of 2-3 millimeters diameter, you can wind around your finger. It's that soft. It's almost like elastic. If it hangs, it looks a little bit like a rope. And that's what people don't expect. So if you have very high purity monocrystal wire, it's extremely flexible and it's not strong. So for silverware, they have to add
stiffening
agents
to it, something to give it a tensile strength, right?
That's it. That's correct. But for wire, that's not the case at all. So for our cables can be extremely pure silver and gold. They will never deteriorate, only keep breaking in even after 100 years. Copper oxidizes at room temperature.
Yeah.
So if you are a manufacturer of copper cable, and we are one too, we have monocrystal copper in our most affordable series called the Explorer. We try to seal it as good as possible that no oxygen or other materials can creep into it. But over time, it's very difficult to maintain its quality. So in general, if you have 10-year-old copper-based cables, even if they were fantastic at today, after 10 years, they're absolutely not the same like they were 10 years ago. And if you compare that with a Siltech cable, that after 10 years, it's only better than it was new, you can see already where we're going and why our brand has such a stable reputation.
Now, I heard you mention electromagnetic wave. That was something that I sent in my original question. Was there is, especially with things like loudspeaker cables, there's an alternating current, and many people feel that the physics model of electricity helps explain how speaker cables work, that it's an electronic wave movement rather than just electron flow. Do you guys consider that? Do you think it matters? I mean, how does that come into your design philosophy?
Yeah, to make it simple, one of our senior engineers, he has a PhD in physics. So if I talk to him about conductivity, 3 days later he stops. And then it's really complex. And
I'm sure, yeah.
I was reading through your question, and I also had a short discussion with him. I said, well, shall we tell about quantum mechanics? Because that's more a precise description based on the atom level and the subatom level. That is, but in reality, for cables, you don't really need that. So the old model, I think it's very, very good to describe a cable. You can describe everything. So we have a couple of things. We have a conductivity. We have inductance, the LCR things.
Yep.
I know there are still people that say it's only LCR, and those are usually the people that don't have the education, but know a little bit of it. I said, okay, what do you think a resistor is? Yeah, just a resistor that goes less current to it. I said, how do you think it works? Would it produce any noise? Is it linear? All of these things. Same with capacitance. Yeah, capacitance is capacitance. I said, okay, what do you mean? 100 picofarad is 100 picofarad. If any person having high frequency experience knows that you need certain types of capacitors to achieve something in high frequencies. Otherwise, you cannot use just any capacitor. So we have also a quality factor in the capacitance. If you go down deep, then you will find there are many, many other little properties in capacitors that all influence the sound and all cause some storage, some storage effects, some delay, some all little things that keeps them off from being linear. So that linearity, I think, in our designs is very, very important. So if we just split it up very quick based on your question. So, oh yeah, that's another thing that you say, yeah, electrons, some people think it's like a water hose where water goes through. That is easy to understand that way. Is it correct? No, it's not correct. But it's not far off from that. I don't know how these things are called. You remember people in the old days on the desk, they had these steel balls next to each other. They were hanging on ropes. Well, that's a little bit how conductivity works.
Right.
So if one electron is you don't see the others moving. They do move slight bit because they get compressed, give back all the energy to the next one, So it looks like only the outer ones are ping-ponging back and forth, and the middle ones are standing still. But at the same time, they're transferring all the energy. That's basically how electron moves, you could say, from atom to atom. There's space, there's free atoms around, and that will displace the charge to the next atom and go on like that. It's actually a very slow process because it doesn't have to be fast because the energy is transferred very fast. So, but the movement of the electrons is very slow. The thing is, when I read it, I thought, well, it's very difficult because if you go into the depth of it, I think for most viewers, it's maybe not that interesting anymore, you know?
Edwin, thank you so very much for your time today. I really appreciate your willingness to sit down and talk about some of these things so that people can get a better understanding, because this experience with Master Crown has been one of the most significant in my entire 50 years around this industry. So thanks again for that.
Greg, thank you very much for the time you give us that we can show how we work to your audience. I'm very happy that you spent so much time listening to us. And again, you talked about the Master Crown. That's the first product to complete it, that we used the knowledge that we now have from musical instruments and we put it in there. That's a world's first. And you will see that trickle down in later products to come that are hopefully more affordable than this one.
We'll leave it at that, sir.
Greg,
listen,
thank
have
you very
a wonderful
much.
time. Thanks for joining us from the Netherlands. And I hope I'll see you guys at a show real soon. Take care.
Thank you very much. Bye-bye, Greg.
Bye-bye. My sincerest gratitude to Edwin for finding time to speak to me from his home in the Netherlands after business hours so that I could present his insights and views to you here on the channel. Further, let me extend my thanks to Siltech and to U.S. distributors Rich Mays and John Baker of Monarch Systems for granting me the privilege of being the first reviewer to audition and report on the remarkable experience of listening to a loom of this new exotic Master Crown series of cables. Now, these cables, as exceptionally well as they performed, are priced well beyond the grasp of the average music-loving audiophile, myself included. The loom I received for evaluation included both a 1 and 2 meter pair of balanced interconnects, a 2.5 meter set of loudspeaker cables terminated with large spades, and a 2 meter IEC AC power cord. Now, I have listed the details of the loom, including its retail pricing, in today's description section, but I will share this much here. That 4-cable loom carries a retail price of $384,700, or nearly 40% of the cost of my entire reference rig, which, all in, carries a retail price just shy of $1 million. So how do they sound? Next week, I will share my extraordinary listening experiences with the Siltech Master Crown loom in play in my reference system, which I must acknowledge as the most musically expressive and revealing loom I've ever had the pleasure of hearing. Till then. As always, thank you for taking the time to drop by today. Further information on supporting the channel may be found in today's description section or at my website, theaudioanalyst.com. Please stay safe and keep the music playing. Till next time, cheers.